Hi everyone, it's Ms. Chow coming to you on Monday on this beautiful day. I'm so excited. So, we're going to talk a little bit first about reviewing the things you learned yesterday, and then we'll move on to some new items, chapters 3.2 and 3.3, which is adding and subtracting rational numbers using fraction notation. So first, I'd like you to look at these two fractions, 6 over 7 and 7 over 9. And I want you to find a number or fraction between these two. What's between them? So we have to find the least common denominator, or a least common multiple. And so in this case, it looks like 7 and 9 won't have any of the same multiples. So we'll take 6 times 7, or 6 over 7 times 9 over 9, which is 1, which is okay. And that equals 54 over 63. And then we take 7 over 9 times 7 over 7, and that equals 49 over 63. So in that way you can tell some rational numbers that are between 54 63rds and 49 63rds. Okay, yesterday I gave you a problem that said, why don't you tell me how to decide the fraction of the number 1.7 repeating. So 1.7 repeating, and we did a couple things to 1.7, multiplied it by 10, and then came up with an answer of the fraction. Today I'm going to ask you to do the same thing, but the fraction is not 1.7 repeating, but it's 0.54 repeating. Okay, and what is that? So we know that if we let x equal 0.54, then, but what we want to do is we want to go over 2 decimal places and not just 1. So we need to have 100x. So we need to multiply by 100 equals, so this, let's say this goes away, and that equals 0.54545454, so on. And 100x then would equal 54.545454. And if you subtract them, then you have, well, I'll write it out again. So you have 100x equals 54.545, let's say, 5454, and x equals 0.5454, and so on. And if you subtract those, you get 99x equals 54, because these all go away. And so then that's x equals 54/99. And we know that that has to be right, or very close to right, because we started out with 0.54, and that's roughly half. And so this also is roughly half. So that's the fraction that fits with that. Okay, next up, to go to the next chapter. Chapter 3.2 and 3.3 have to do with adding and subtracting rational numbers and using fraction notation. So I'm just going to go through a few examples here of this. I'm going to switch out my pen color because that just makes it more fun, for me anyway. So the first thing is, the first example is blank minus 18.2 equals 27.35. So what do we have to do to solve this? So what we have to do is add 18.2 to both sides, right? 27.35 plus 18.2. And so that equals, I know the answer, 45.55. Okay, so that's just simple math. Another one is we have minus 7.24. Sorry, it's too hard for me to write. And what you're welcome to do too is if you want to do these without, in your own pace, you can certainly write them down and then stop the recording and then go back to them again. So minus 7.204 minus negative 1.8 equals something. Okay, so in this case, we know a negative and a negative gives you a positive, right? So that's minus 7.204 plus 1.8 equals, and I'm just going to tell you the math, it equals minus 5.404. Okay, and the last one is 3.43 plus 2.98 equals 6.41. Okay, the next thing we're going to do is addition and subtraction using fractions. So if I say, okay, I have 5/3 plus 2/3, what does that give you? Well, the denominators are the same. So if the denominators are the same, that means we can just add the numerators. So that's adding 5 plus 2 and getting 7 over 3. Another example is 4 over 7 plus 3 over 7 gives you, and here again, the denominators are the same. You can just add the numbers together on the top, the numerators, pardon me, and that gives you 7 over 7, which equals 1. Okay, another concept in this chapter is the concept of converting mixed fractions to improper fractions. So a mixed fraction, what is a mixed fraction? Example. So a mixed fraction is, say, 5 1/8. Whoopsie. Well, 5 1/2. That's another mixed fraction. And an improper fraction is a fraction where the numerator is bigger than the denominator. Say 11 over 6. Improper fraction. You simply multiply 2 times 5, or the denominator times the number out here, and then add the 1. So it would be 2 times 5 plus 1, which equals 11. And so the improper fraction is going to be 11 halves. That's the same as 5 1/2. Another one we have, suppose we have 5 1/8. What does that equal? Well, 5 times 8 is 40, plus 1 is 41. So that's 41 over 8. All right. Another one comparing, so if we have an improper fraction example, and we have 35/6. Well, 6 goes into 35 how many times? It goes in 5 times. And then that would be 6 times 5 is 30, so then there's 5 left over up here. So then that gives you 5/6. Or another example is 29/3. So then you say 3 goes into 29 9 times, and then that leaves 2 left over because that's 27. So 29 minus 27 is 2, and that's 2/3. Okay. Now I'm going to show you some fun stuff. So the least common multiple, we're going to write it this way. And I think I'm going to stand over here. Oh yeah, that's much better, isn't it? So the least common multiples, denoted as LCM, equals the least common multiple. Okay, so the least common multiple is of two natural numbers is the smallest number that's a multiple of each number. So for instance, if we have the numbers 24 and 36, then the least common multiple of these two numbers, the way you can figure it out, you can use prime factorization. Do you all remember what prime factorization is? It's where if you have a number, say 8, and you break it down into the lowest prime numbers. So 8 is 4, so that's 2 times 2 times 2. Or 6 has 2 factors. It has 3 and 2. You can break that down, I would say 6 and 4. And you can further break that down to 2 and 2 and 3 and 2. So here, these four numbers multiplied together give you 24, and they are the lowest numbers, they're the prime numbers that are affiliated with this number here, this big number. 36 is something similar. It's suppose 6 and 6, which is 3 and 2, and 3 and 2. Now, if you write this out and you would say 24, okay, so there's 3 2's, so that means that it's 2 to the third times this 1 3 times 3 to the first. And over here, you have 2 squared times 3 squared. Now, in order to come up with the least common multiple, the lowest common multiple, if you look at this, 2 thirds, 2 to the third times 3 to the first, and 2 squared times 3 to the second. In order to come up with the least common multiple, you need to pick the biggest number from each of these base numbers. So 2 to the third is the biggest. 2 to the third is greater than 2 to the second. And 3 to the second is greater than 3 to the first. So if you have 2 to the third, that means that, and 2 to the third times 3 to the second, that means that this will go into that number, because it's 2 to the third times 3 to the first. And this will go into that number because it's 2 squared, and this is 2 to the third, times 3 squared. So that's going to work too. So 2 to the third is 8 times 9 is 72. 72. So between 24 and 36, 72 is the least common multiple. So if you had an equation, suppose 11, how far can you see me? Can you see me over here? Yes. So if you have 11, like say 11 over 24 minus 17 over 36, you would be able to figure out the number, the least common denominator, using the least common multiple of each of these numbers, and then, which is 72. We just figured that out. So 72. Now, how many times does 24 go into 72? Well, I think that's 3. So it would be 11 over 24 times 3 over 3. And that gives you 33 72s. And then 17 over 36, well, 36 times 2 gives you 72. So it's 2 over 2, which is 34 over 72. So they're very close. But you know which is bigger because you were able to find the least common multiple and then put it into the denominator and then figure out the relationship. There's another way to do this that I'm thinking somehow I always end up doing because I forget how easy things can be. But if you want to find out, suppose you have 24 and 36. And if the numbers were pretty small, you could always say, okay, I know 24, 48, 72, and then there's some more, 96, and I know 36 and 72. Go figure. So if the numbers were easy enough, you can sort of brute force your way into the right number, into the right, the least the common denominator. But really finding the least common multiple is the more efficient way, and it's consistent. So let's look at one more example of this. Suppose you have 18 and 12. Okay, so for 18, your multiples are 9 and 2, and 9 is 3 and 3, and 12 is 4 and 3, and 2 and 2. So we know that then you can write this as 3 squared times 2 to the first, and this is 2 squared times 3 to the first. So 3 squared, 2 to the first, and 2 squared, 3 to the first. So your answer is going to be, your least common multiple is going to be 3 squared times 2 squared. Because you want to use the bigger one. And you know, because this, 2 squared goes into 2 squared, and 3 squared is greater than 3 to the first. And over here, 3 squared to 3 squared, and 2 squared is greater than 2 to the first. So this is 9 times 4, which equals 36. So between 18 and 12, you know 36 will be your least common denominator using this least common multiple method. All right. We are going to have office hours tomorrow, Tuesday, and then Wednesday and Thursday at 11 o'clock. Just if anybody has any questions or you want more information about anything math or anything really. All right. Have a great night. Bye now. Okay, one last thing. I want to give you the homework. So it's section 3.2, page 98. Number 4, the odd ones. Number 6 to 7 is also the odd ones. And then 9 to 13, all. And then section 3.3, page 105, numbers 1 to 10, odd, 11, 13, 15, and 17. Okay, bye now.